Okay. In A3, there was also another discussion that we had talking about transforming exponential functions. So let's talk about transformations. We've already done transformations so much already. Let's say I have the function that I need to graph. And for fun, I'm going to do a different base totally. All right, let's talk about everything that's happening to this graph. This 2 in front here, that is a vertical stretch. And when I get ready to do that vertical stretch, I'm going to show you all the details of that in, let's go with in orange. So we'll know that this is in orange. Okay. The next part is this -3 up here. If we remember our rules, this is going to move me right 3. So let's choose a nice lime green. So when I talk about moving right 3, I'm going to use lime green. So everybody knows that's what that means. This last part is moving up 2. So when I decide to move up 2, I'm going to use, let's see if I have a nice color. Ooh, let's use a blue. Here we go. All right, so we are going to end up graphing all of those. But to begin with, I need to use what is called a little parent function. A parent function isn't shifted at all. It's the most basic you can get. So the parent function be y equals, you start to have the same base, but you're not doing anything crazy to it. So that's what we're going to start with. So I need to do x and 1/2 to the x. And I chose a really weird base because I really wanted to make sure we were okay with fractions. I know some of you get scared of them and run away, but they're not evil. 1/2 to the -3, 1/2 to the -2, 1/2 to the -1, 1/2 to the 0. Oh, I know that one. It's 1. 1/2 to the 1. That's 1/2. 1/2 squared. Oop, that's 1/4. 1/2 cubed. That's 1/8. Cool. I know those. Now, going backwards, it looks like it's kind of going opposite of what we've done before. 1/2 to the -1 will flip it and turn it into 2. This would flip and be 2 to the +2, which is 4. This is going to be 8. So we can really see how those negative exponents play. I want a nice, pretty grid here. Now I'm having to make it myself. If you're lucky, maybe you have graph paper at your house. I don't. 4, 5, 6, 7, 8. I might want to go a little bit further. 9, 10, 11, 12, 13, 14, I don't know, 15, 16. I'm just going way up there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. Okay. I'm going to go ahead and sketch this parent function. When x is -3, I'm at 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. When x is -2, I'm at 4. 1, 2, 3, 4. X is -1, I'm at 2. When x is 0, I'm at 1. When x is 1, I'm at 1/2, and so forth. And I've got that beautiful horizontal asymptote. So let's make sure we note that. There is a horizontal asymptote at y equals 0. Hey, while I'm there, what is my domain? What can I plug in? Any old thing I want. It's a -infinity to infinity. What about my range? Now, if we look closely at our range, we're only getting positive numbers back, and we're never touching 0. So, It's 0 to infinity. All right, next thing I'm going to do, and I told you I'd do this in orange. In orange, I'm going to vertically stretch it. Now, vertically means I'm affecting my y values. So here's where I'm going to do the stretch. It's actually really easy to do if you start with your table. If I'm stretching by 2 vertically, that means I'm affecting my y values. 8 times 2 is going to be 16. 4 times 2 is 8. 2 times 2 is 4. 1 times 2 is 2. 1/2 times 2 is 1. This would be 1/2 and 1/4. I'm vertically stretching. So I'm taking each of these points. This one was at 8. Now it's going to be way up here at 16. This one was at 4. Now it's going to be at 8. This one was at 2. It's going to be at 4. So everything is getting doubled. So it literally pulls it all up. Now it still has that same asymptote. That hasn't changed any. But now I have stretched. Okay. Now the next movement is right 3. Said I was going to do that in lime green. So here we go. To go right 3, I take each of my points and I'm going to literally move right 3. Let's see, where am I? 1, 2, 3. 1, 2, 3. 1, 2, 3. This one, 1, 2, 3. Is this affecting my horizontal asymptote at all? Nope. It's still where it is. Hasn't changed that a bit. Now, my next movement is to go up 2, and I'm doing that in a very pretty blue. Up 2, up 2, up 2. This was 1, so up 2 would be there. What is that going to do to my horizontal asymptote? Well, guess what, folks? Everything moves up 2, including my good old horizontal asymptote. So now I've moved up. I'm in my final position, and something happened. The horizontal asymptote moved. It is now at y equals 2. So we've got a pretty good idea by looking at the graph. If it's going to move vertically, that's going to change that horizontal asymptote. So there's a good shortcut for you.